Hello, dear friends. In order to understand covalent bond, in last video lectures we saw first two example of formation of molecule on the basis of covalent bonding. Myself, Dr. B.V. Pawar, working as assistant professor in Department of Chemistry in Arts, Commerce and Science College, Jagar. Today we are going to learn the formation of molecules, diatomic, simple homodiatomic molecule with the help of valence bond theory, as well as here we will study first example of, that is, helium molecule. As we know that molecule is nothing but what, the combination of two atoms of different elements. When combined in a particular ratio, there will be a formation of molecule. So here, when two helium atoms combines, then there is formation of a helium molecule. So student, remember, in nature helium is not exist in a molecule, but it is exist in a atomic form. Why not this helium is not exist in a molecule form? That we will study here today. Before going to understand that why helium is not exist in the molecular form, let me study that helium atom has atomic number 2. In periodic table, helium is the second element or second member of the periodic table. So atomic number of helium is 2. Electronic configuration of helium is 1s2. What is electronic configuration? Electronic configuration is actually nothing but what, the distribution of electrons. That means when electron is distributed in a molecule or in an atom, that can be shown in the form of electronic configuration. For example, I have an atom, that is this, let's say this is a helium atom. In this helium atom there is a center called as a nucleus. In that nucleus there is a presence of two important constituent. One is called as one is called as neutron, and second one is a proton. And electron is revolving around the nucleus in a shell. So this is a shell. In that, the capacity of first cell is to accommodate only 2 electrons. So both 2 electrons will be returned or will be present in a first cell, and that's why in electronic configuration we have written 1 means first cell. In first cell there is presence of s orbital, and in that s orbital there will be 2 electrons which having opposite spin. For example, like this, 1s2. This is the electronic configuration of helium atom. In this helium atom, both electrons are paired, and therefore its orbital is completely filled. Actually, first cell is the outermost cell of this helium atom, and therefore both electrons are already filled in a valence shell, so there is no electrons available for bonding. Since there is no unpaired electrons, there will be bond formation does not take place, because bond formation by sharing of electron does not take place, because it doesn't having any electron to share with other. And therefore in nature helium is exist in monoatomic form or monoatomic element in a gaseous form. Remember, helium is a gas, right? Under normal condition, helium molecule does not exist because it is not in the form of molecule, but it is in the form of atom. However, decomposition of helium molecule to helium atom takes place or favored due to entropy, because one molecule of helium, when dissociate, it gives two atoms of helium. So that means one molecule is converted into two atoms. So it is entropically favorable. What is entropy? Entropy is nothing but it is a measure of randomness. So as number of atom increases, randomness also goes on increases, and this is favorable, and therefore helium exists in the form of molecule. Sorry, it is exists in the form of atom and not in the form of molecule. Okay. Now second molecule is a lithium molecule. In periodic table, lithium is the third member, and therefore its atomic number is 3. It has 3 protons in a nucleus. Then there is a 3 electrons which are revolving around the nucleus in a shell, and therefore these 3 electrons can be shown in the form of electronic configuration as 1s2, 2s1. So I will show you. This is first cell of lithium, this will be second cell of lithium. In first cell there is s orbital, in second cell there will be 2s orbital, one for first shell, 2 for second shell, and then both cell having a s orbital. Now here there is 3 electrons. Out of 3 electrons, 2 electrons will be filled in a 1s2 orbital, because its capacity to accumulate electron is only 2, and in second cell you can fill 1 electrons. Now here first cell is already completely filled, but second cell is a half filled. There is 1 electron which are unpaired in a 2s orbital called as a outermost shell. It is really exists as a diatomic species in the form of gas because it has 1 electron unpaired, and this 1 electron in a valence shell share this electron with other lithium atom by sharing, and there is formation of lithium sigma bond. Okay, so everybody remember, here s orbital of first lithium atom overlap with another s orbital of second lithium atom. So this is, let's say, 2s orbital of lithium, this is 2s orbital of lithium, this is first lithium, this will be second lithium. So in both there is a one single electron. When they share their electron, now it become a paired. So when these two atoms orbital overlap, then there will be formation of a lithium single bond, and now here this is the axial overlap, so therefore there is formation of sigma bond. Everybody understood? So this kind of overlap is called as SS overlap. Everybody understood? Now this can be proved that when you do the its examination of crystal structure of lithium atom, then we found that lithium atom is surrounded by, each lithium atom is surrounded by nearest other 8 atom, and therefore its coordination number becomes 8. Okay, because it has 8 neighbor atoms. This is the second molecule. Now we will go to the next molecule called as a beryllium molecule. Now let me see whether beryllium molecule is existed or not. Now beryllium is the 4th element in periodic table, therefore its atomic number becomes 4. If you saw, the electronic configuration of beryllium is 1s2, 2s2. How? Let me see, this is first cell, this will be second cell. First cell having one orbital called as 1s, second cell having another orbital called as 2s. In first cell there is 2 electron, in second cell there is 2 electron. Okay, now again in outermost shell there is a two electron, because first shell is a inner shell which is not important for bonding. Outermost shell called as a valence shell, and therefore it is important for bonding. So in outermost shell there is a s orbital, and in that s orbital there is a two electron which are paired. Okay, so according to atomic orbital concept, beryllium behaves like a noble gas because both electrons are paired. In 2s both electrons are paired. Since there is no half filled orbital, but is it possible, or is it really? That can be understood with the help of valence bond theory. Is it really exist as a diatomic molecule in a gaseous form? As such, beryllium has a zero valence. If there is a two electrons which are present in two s orbital, that means it is a zero valent. But this is not so easy. However, promotion of 2s electron to 2p orbital in the excited state, now that can be possible. That means in ground state electronic configuration is what? 1s2, 2s2. But when you supply some amount of energy, what happen? Here in ground state 2p having 0 electron, because second shell are having also 2p orbital. So what happen? There is a excitation of electron takes place from 1 2s orbital to 2p orbital, and therefore electronic configuration becomes 1s2, 2s1, 2p1. Okay, now when there is a transformation of electron takes place from 2s to 2p, at that time now this particular beryllium atom now have two half filled orbitals, and therefore it shows a bivalency 2. Again question will rise in mind, is it possible that the promotion of electrons from 2s to 2p orbital, how it is possible? Yes, it is possible at very low energy, because the energy released by the formation of two covalent bond which are energetically feasible, and because there is a promotion of electrons could take place easily. Now let me move to the next molecule, that is a boron molecule. Now here mistakenly beryllium is written, but there will be a boron. Boron has atomic number 5, and therefore for this boron electronic configuration becomes 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. Everybody understood? Boron having atomic number 5. That means boron having how many electrons? 5 electrons. Remember, whatever the atomic number, same number of electron will be present in that element. 1s2, 2s2, 2p1. So these are this is the electronic configuration of boron. So this can be written in the form of this. One s2, 2s2, 2p1. Now 3 electrons present in a valence shell. So valence shell electronic configuration of boron is 2s2, 2p1. Now here in valence shell of boron, actually 2 electrons are paired in 2s orbital and 1 electron is unpaired in a 2p orbital. But it has 1 electron in p orbital which is half filled. When two boron atom approach, and if x-axis assumed to be molecular axis, then overlap of 2px orbital of two boron atoms along x-axis produces boron-boron sigma bond. Thus, B2 molecule is formed by a single covalent bond with structure like this. Boron, boron, and there is presence of 2 electron as a lone pair of electrons. Okay, so it suggests that each boron atom has one lone pair of electron. According to valence bond theory, boron molecule is diamagnetic in nature because it's both electrons in a boron molecule is a paired. If electrons are paired, then that species become a diamagnetic. If there is unpaired electron, then it is paramagnetic. But this is not true because boron atom has one half-filled orbital which behaves as a univalent, and therefore this can be confirmed with the help of many examples like BCl3 BH3 molecule where boron is a trivalent in nature. So we require to simplify why boron exists in a trivalent manner and why not in a monovalent. So this is required another important modification to study. So this is about the B2 molecules. In next video lecture we will see C2 molecule, N2 molecule, F2 molecule and Ne2 molecules. Okay, so now we will stop here. You all are requested to study up to this point in today's lecture. Okay, thank you.